Tonight, we explain why Lizzie is finally able to reach her caterpillar. And here with some science news, he is the matter to your universe, Mr. Matthews.
Hello everyone and welcome to another edition of Science News. The news that matters. See what I did there? The news that matters, matter in science. Okay, alright, tough crowd today, tough crowd. Alright, so today's video is going to deal particularly with force and acceleration patterns. Before I begin, I want to give a shout out to some students who commented on the surprise video that I posted a little bit earlier today. Yahira, Braden, Mohammed, Tanya, Jimena, Miracle, and Gustavo. So those students, I want to give you a shout out. I give you a shout out and thank you for commenting your answers. And those of you that did not comment, and even those of you that did, I want to challenge you to go back to your answers and give me the reason or how you got your answer. Justify your answer. Give us the why. Give us the how. If you said 200, if you said 96, if you said 4,786 and 76 tenths, give us a reason why you got your answer and how you got your answer. All right, today's lesson is going to involve the I can statement here. I can make observations and measurements of an object's motion to provide evidence that a pattern can be used to predict future motion. That's the key here, the idea of a pattern. I want to make sure that that is very noticeable, a pattern. That's the key word here. A pattern can be used to predict future motion. And the essential question is, how can you tell when something's moving? Sounds like a simple question. But as we go through this and review, a lot of this will be review from 3rd and 4th grade material. So we're going to be looking at some 10 ready style questions on this particular standard that really challenge what we know of how can you tell when something is moving. All right. For today's lesson, we're going to have a few vocabulary words that we need to take a look at. The first one is motion. And motion is just simply when an object is moving or is being moved. All right, when it is moved or if it is currently moving. And we have here a picture of a cheetah here. And then we have the word pattern. When something repeats, we deal a lot of times with patterns in math. For example, Ms. Satchel posted a couple of coordinate plane videos. And if you have a diagonal line or a straight line, sometimes you're going to see patterns in their X coordinate or in their Y coordinate. Feel free to refer back to her videos on those coordinate planes. Then we have the word friction, and friction is just a force that is resisting motion. So for example, if you take your hands and you rub them together, that is perhaps one of the best examples of friction. If you rub them together really fast, your hands are going to start to heat up. Well, that's due to friction. Then we have pattern of motion, when an object makes the same pattern again and again. So when an object is making the same pattern of motion. And then we have the outcome or the end result of a test. So for example, some synonyms for the word outcome: answers, findings, conclusions, the results, the solutions, and then again the word outcome. All right, so let's take a look at this 10 ready style question. And some of you may find this question familiar to you because we've looked at it in class, but I really want to take a moment to really go through it again and really kind of adapt it to this particular skill of being able to identify these patterns. All right, so let's look at the question. Let me get my annotation tools ready. So I'm ready to annotate, because remember, we always want to be able to annotate whether it be word problems or even science problems. A student is swinging on a swing. The table shows data. There's a math word there, data, on the position of the student during 6 seconds. Okay, so I'm going to be looking at data for 6 seconds. 0 seconds, 1, 2, 3, 4, 5, 6. So here I have just a regular T-chart. Let me adjust these blinds a little bit because it's getting a little, there we go. All right, so I have a little T-chart here that's got data in it. So it says student position, 0 seconds all the way to 6 seconds. And then position, what do we call these in math again? Does anybody remember? Yeah, they're just variables, all right, just letters that could stand for numbers, or in this case, different locations. So here we have the person, we'll call him, I don't know, what do you want to call him? All right, Alexander. We'll call him Alexander, Alex. So here's Alex. Alex is starting at point X. This is where he's starting. So I'm going to put a little S right here. That's where he's starting. And then he goes back and forth. I'm sure we all have swung by swings before, or swung on swings, I guess is the correct term. So he's going back and forth. In other words, you're noticing a pattern there, back and forth, back and forth. All right, let's take a look at the question. Which two predictions? That's nice that they underline that for us, but I'm going to circle it. And I'm going to write a number 2 above there, because that's going to let me know that I need 2 answers, not just one, 2 answers. Which 2 predictions show where the student will be if the pattern continues? Okay, so in other words, I'm being asked to continue this table. All right, well, let me just kind of extend this table over here. So I'm going to go, I know I'm going to start at 7 seconds, and then 8 seconds, 9 seconds, 10 seconds, and 11 seconds. Okay? Now let me see. Right now, at 0 seconds, he's at X. So at 0, he's there. At 1, he's here. At 2, he's here. At 3, he's where? Y, okay. So at 3, he's coming back. At 4, he's back home, if you will. At 5, he's back to Y. At 6, he's back to Z, okay? Now, where would he go for 7? Well, if he's over here at 6, he's going to come back over here. So let me change this color so I can show that that's different now. So he's over here now for 7. So at 7, he's going to be at Y. All right, where's he going to be at for 8? Is he going to go to the left, or is he going to go back to the right? Yeah, he's going to go back home. He's going to go to the left. So if he's at 7 here, he's going to be at 8 seconds over here at X. And then 9 seconds. Again, we're seeing a pattern here, back and forth, back and forth. All right. So at 8 seconds, he's here at X. Then he's going to keep going back. 9 seconds, he's going to be here at Y. 10 seconds, going to the other side. So that's at Z. And then 11 seconds, he's going back down to Y. All right, so let's see if there's a pattern here that we can tell. X, Y, Z, Y, X, Y, Z, Y, X, Y, Z, Y. So we're noticing a pattern here. Remember we talked earlier about this idea of a pattern of force and motion. There's a pattern, a back and forth pattern, particularly with this swing. All right, so let's see which answers match up our work here. 7 seconds at point Y. 7 seconds, point Y. All right, sounds good to me. That matches what we have. So I'm going to select that one. B, 8 seconds at point Z. 8 seconds at point Z. No, we said 8 seconds at point X. So that one's not right. Again, I'm using some annotation skills. I've annotated the problem, and I'm starting to go through my answers, and ones that aren't right, I'm crossing them out, getting them out of the way. Get that out of here. All right, at 9 seconds, he's at point Y. Not X. That's not right. At 10 seconds, he's at point Z. Not X. Get that out of here. All right, 11 seconds, point Y. 11 seconds, point Y. There we go. All right, so we have found 2 predictions. Notice, we didn't actually see him get to these seconds, but we were able to predict a pattern based on this motion, based on this movement of back and forth. All right, now let's go on to another problem. I know many of you will recognize this problem because we've done this a few times in class, but it's interesting how science and math connect with each other. You'll see in this problem and even in the problem previously that math is a very important skill needed, and math and science really tie together perfectly. All right, so let me get my annotation tools ready. Let's see, what color do I want to use this time? Who said violet? Okay, we'll use a little purple. I think this is violet. I'm not an art teacher. Okay, the picture shows a carousel. How many of you ever ridden on a carousel? I have. I get dizzy real easy. I don't much like carousels. Even though they go real slow sometimes, I just am not a big fan of carousels. All right, so the picture shows a carousel. Here's the carousel. The carousel spins while the horses move up and down. So as it's spinning, the horses are going up and down as well. A student determines that each horse completes one up and down cycle in 30 seconds. So in the time for this horse to go up and down, that takes 30 seconds. 30 seconds. All right. And I'm going to annotate that. One up and down cycle in 30 seconds. The student rides a horse on the carousel for 2 minutes. Which equals 120 seconds. Okay, that's pretty interesting to know. That's a nice little conversion problem there, like the surprise video conversion problem. 2 minutes equaling 120 seconds. 1 minute's how many seconds? All right, good. 1 minute, 60 seconds. So we just multiply that by 2, which is how they get the 120. All right, let's go to the problem. The question. How many times did the student riding the horse complete an up and down cycle? So if we know that it takes 30 seconds for one up and down cycle, we want to know a pattern, basically, of how many times that student went up and down in 120 seconds. So a couple of different ways we could do this. We could say, okay, one time was 30 seconds. 2 times. Again, we're kind of making a little T-chart here. A little T-chart. 2 times would take how long? Good, 60 seconds. We're just multiplying 30 by 2. 3 times would take how long? Good, 90 seconds, good. And let's go to 4. 4 times is what? 120 seconds. Okay. Well, let's continue because our most is 5 times. So let's see what 5 times would be. 5 times would be what? Good, 150 seconds. All right. Now our question says, how many times did the student riding the horse complete an up and down cycle? So they rode for 120 seconds. 120 seconds. How many times? 4 times. Good. Let me show you another way you could have gotten that. You could have asked yourself a really higher level math question here. How many 30 seconds can fit into 120 seconds? What order of operation would you do for that? If you'd want to take that 120 seconds and split it up. Let me use that term. Split up. Or divide. Yeah, division. You could have taken 120. This is going to be fun on the computer. 120 divided by what? 120 divided by 30. Yeah, good. And remember, what can I do here? What can I do to make this a little bit easier for me? What can I do? Good, I can cross out the zeros. I hope that's what you said. I can cross the zeros out. If I cross a 0 out here, I'm able to cross it out here. But remember, if you have more than 1 over here and only 1 here, you have to make sure you cross out the same number of zeros in your divisor as your dividend. All right, so that leaves me with 3 divided into 12, or 12 divided by 3, which is what? 4. Yeah, not so hard. 4 times. 4 times. So I hope you're able to see that there's a pattern here that you can start to determine based on knowledge that you're given in the beginning. Like in the first problem, we were given a swing, and we knew that that was going to be a constant back and forth of locations. You start here, actually here would be on your screen, and you go this way. All right, and then on this carousel, you're going round and round and round. So based on that, and if you look at the video in the very beginning, Lizzie was able to determine where her caterpillar toy was going next. So she knew if it goes back and forth, then she knew where its next motion was, its next movement, to where she could grab it right there. All right. All right, let's take a look at a exit ticket for you. I think you'll like this one. All right. I want you to go to this website. A lot of us have seen these type videos, Generation Genius. I'm going to put the link down in the description below this video. So when you go there, you're going to watch this video on patterns of motion and friction. And this is free right now, so you can feel free to watch this video. It's a wonderful video, and I know you all love these when we watch them in class. After you watch this video, I want you to scroll down here to where it says exit ticket. All right. And then here's your exit ticket. In the comments below, I want you to put your answers. Remember, complete sentences. Put your answers in the comments below of all 3 different level questions on your exit ticket. Okay. After you do that, only after you've done that. I know some of y'all be trying to answer some of this stuff and watch this video without having to do some of this work. You better answer some of these questions. All right. After you have done those exit ticket questions, I want you to scroll back down here. Here's the part I know you'll love. To the online quiz game. Online quiz game. You're going to click that, and you're going to click quizzes. I know y'all love quizzes. All right, so you're going to click quizzes, and then here is a fun quiz game based on the video. Okay. All right, I hope you've enjoyed this lesson, and please leave your comments below as answers to your exit ticket. And I can't wait to read those, and I can't wait to see you next time. Hope you and your family are doing well and having fun and learning together. Until next time, Mr. Matthews out.